Hello students, let's talk a little bit about how we do the heat problems. So we do have an equation for our heat problems, and here it is. It's Q equals mc delta T. Okay, Q equals mc delta T. Do not be intimidated by this. We will use the same problem solving steps for this equation as we have all the others in the past. So what do those variables stand for? Well, it almost makes no sense, but Q is what we use, capital Q is what we use for heat, right? Our heat energy. M is going to be for mass, right? In how much stuff that we have that gets heated up. And then C is that something that we call specific heat capacity. That's kind of like thermal inertia. We can think of specific heat capacity as how much energy is required to take something and warm it up, or how much energy would we need to get rid of to cool it down, right? Some things need lots of energy to change their temperature, other things do not. And then the delta T is our change in temperature, and that has to be a capital T, right? Because lowercase t would be for time. So you notice that we do have a delta, and anytime we have a delta, we always expand it. So it's always the final minus initial. Sometimes people will write it as T2 minus T1, or they might write TF minus TI. Right? It's really the same thing. People are just choosing to use different subscripts for this. So what I'm going to do is I'm going to walk us through a couple of practice problems using this equation. And I know that it looks a little daunting because we've got 4 variables. There's a delta that's in it. So we have a couple of choices for when we start moving things around. We could use algebra, but I also have a trick, a circle trick that we can use that makes it as a shortcut so there's less algebra involved. Okay, so what I'm going to do is I'm going to put a problem up on the screen, and then we're going to go through that problem together. Okay, great. Okay, what I've done is I've just written the equation that we just talked about right here, so we have it for reference. And I did tell you that there is a way to do this so that you don't have to use as much algebra. So there is a circle trick. So all I'm going to do is just draw a circle like this. And we've done this before with some of the energy equations. And I'm going to draw it this way. And on the top I'm going to put a Q. And then I have my M, C, and then I have my delta T. And so whichever one of these terms that I want, I just cover it up, and then I write out what's left. So if I cover this up, the Q, you can say I have mc delta T next to each other just like this. If I wanted mass, then I would have Q over C delta T. If I wanted to solve for the specific heat capacity, I have Q over M delta T. And if I wanted to solve for the change in temperature, then I would have M over MC. The problems that we're going to do right now, they're in our textbook, so you can follow along. They're starting on page 425. I'll write that up here, page 425. And we're just going to do a couple of these. So the first one we're going to do is number 23. So this question reads, it says, calculate the number of calories of heat needed to change 500 grams of water by 50 degrees Celsius. Our unknown variable for this one is Q. Now, it does say, and we want this in calories. Now, the fact that it says calories means that we can now choose which specific heat capacity to use, and based on the one that we use, then we'll know which units to use for mass. So I'm just going to write here that we have water. And so the reason I write that is because the specific heat capacity for water, if we're using calories, is simply 1, and it's calorie per gram for every degree Celsius. So the units are kind of wacky. But because I have right here grams, then I can use mass in grams. So this just is 500 grams. And it says in this problem that the water changed temperature. It gave us a delta T of 50 degrees Celsius. So this one is very straightforward. All that we need for this is Q equals mc delta T. And we don't have to do any algebra. We don't have to expand the delta because of the way the problem is written. We'll just put all the numbers in. So Q equals, we've got 500 grams this is water, so the specific heat capacity is 1 calorie per gram degrees Celsius. And then we've got our 50 degrees Celsius for our change in temperature. Calculator does all the work, and we end up with 25,000 calories. So this is how we do number 23. We could change this to joules if we like, because 1 calorie is 4.18 joules, but the problem doesn't ask us to do that, so we're just going to leave it like this for now. What we are going to do, though, is we're going to go and look at number 24, the next one. So this question reads, calculate the number of calories given off by 500 grams of water cooling from 50 degrees Celsius to 20 degrees Celsius. So again, we're asked to find Q, and it does say calories, so I'm just going to make a little note. If it said joules, then I would write a J over there. And once again, it says that we're dealing with water, so I'll make a note of that, because the specific heat capacity of water is 1 calorie per gram degrees Celsius. And you don't have to remember the specific heat capacities. They'll either be given to you if you need it to calculate the problem, or it might be your unknown if you're asked to find what the specific heat capacity is. For this problem too, it says that the mass, once again, is 500 grams. But now we have two temperatures. Our first temperature, T1, was 50 degrees Celsius. And then our second temperature, because it's cooling down, is 20 degrees Celsius. All right? And it does make, it is important, it does make a difference as to if you have these in the right order. So in this case, the hot temperature is the first one, the cool temperature is the second one. So what this means is that we're going to end up with a negative number, but that's okay, because if we go back and look at what the problem reads, it says calculate the number of calories given off. So these are the amount of calories that we're going to lose. Now, based on what we have listed here, we've got Q equals MC delta T, but now I have two different temperatures, so I have to expand my delta T. So I've got Q equals MC T2 minus T1. This is the equation that we can use to solve number 24. Let's put the numbers in. Q equals, we've still got our 500 grams. Specific heat capacity of water, 1 calorie per gram degrees Celsius. Our T2, 20 degrees Celsius. T1, 50 degrees Celsius. And so you can see over here, we've got our negative leading to the bigger number, so our answer will be negative. The calculator does all the work. We get negative 15,000 calories. So this is the amount of calories that is given off from this cooling. Let's try one more problem. For this one, we are going to do, change the color again, number 27. So it's on the same page. We're on page 426 in your book. So this shifted to 425 to 426 in your textbook. So let's go to number 27. We'll do this one under here. So this problem reads, what mass of water will give up 240 calories when its temperature drops from 80 degrees Celsius to 68 degrees Celsius? So we want to find what is the mass. And it does say water. So I'm going to list that again, because the specific heat capacity for water, if we're dealing in calories, is 1 calorie per gram degrees Celsius. And it says that for this problem, we have given off 240 calories. So that's a negative. And it says that we have an initial temperature of 80 degrees Celsius, and we have a final or a second temperature of 68 degrees Celsius. Now for this problem, we've got Q equals MC delta T, but for this problem, we need to solve it for M. So that's where we can use a little bit of algebra, or we can use our triangle trick up here. If we use the triangle trick and we cover up the M, then we can write M equals
Q over C delta T. Now there's one other thing that we should do for this problem. Because we've got a delta T here, but I've got two temperatures here, we really should expand this delta T. So we'll rewrite this one more time. M equals Q over C, and then for the delta T, I'll have T2 minus T1. So I'll expand that delta T. So this version here will solve this problem. And we'll just put all the numbers in once again. So we've got our negative 240 calories. The specific heat capacity for water is 1 calorie per gram degrees Celsius. T2 is 68 degrees Celsius. T1, 80 degrees Celsius. Calculator does all the work. We don't have to worry about breaking the universe for this one. This will give us a negative under here, but this is a negative on the top, so those will take care of each other so that our mass is not a negative mass. That would be really great if we could figure out that negative mass business, but unfortunately this problem doesn't do that for us. We put all the numbers in, and the calculator gives us 20 grams. So that's how we do these problems. We'll use our Q equals delta T. Sometimes we have to expand the delta T, so it's final minus initial, or T2 minus T1. And then sometimes we have to use algebra, or we can use our triangle trick, circle trick over here, so that we can solve for other variables besides Q. We can solve for mass, we can solve for C, and we can solve for delta T. So there's a few problems that are assigned. Some of these are actually the ones that we just did, so we've taken care of part of the homework, or the activities, whatever you like to call it at this point. Give the rest of those a try, and let me know if you have any questions.